Okay, now we're going to do number 7. From our equilibrium review packet, this is the last set of questions in that equilibrium review packet. We have a 500 milliliter flask. It's injected with 0.72 moles of H2 and 0.72 moles of C2N2. We want to know the equilibrium concentration of the HCl. So we have our reaction here, and we're going to make an ice table. And since we're given that we have a flask and we inject some H2 and some C2N2, we need to find their concentrations. So 0.72 moles of H2 divided by 0.5 liters is 1.44 molarity of H2. And since the number is the same number of moles for the C2N2, we'll also have 1.44 molarity of the C2N2. And technically we should have 2 sig figs here. I'll go ahead with these for right now. We have no HCN in the flask. So in order to reach equilibrium, we're going to have to make some product. So we're going to lose x and x, but since it's a 2-to-1 coefficient, we're going to gain 2x. And so at equilibrium, we'll have 1.44 minus x, and we'll have 1.44 minus x and 2x. And we know that K is equal to the concentration of HCN squared over the concentration of H2 times the concentration of C2N2. And so we can plug in that 1.2 is the K that was given, is equal to 2x squared over 1.44 minus x squared, because it's 1.44 minus x times 1.44 minus x. So the easiest way to do this problem is to just realize that this is a perfect square on the right side. And we can put the squared outside of the whole fraction. And then, to solve this, we'll just square root both sides. So when you square root the right-hand side, you get 2x over 1.44 minus x is equal to the square root of 1.2, which is 1.095, 1.10. So I'm going to leave it because I like to keep all my numbers while I'm still working. And then we'll multiply both sides by the denominator of this fraction. And when you do that, we get 1.44 times 1.095. So that becomes 1.577 minus 1.095x equals 2x. Add the 1.095x to both sides. And we get 1.577 is equal to 3.095x. And so divide both sides by 3.095. And we get x is equal to 0.51 molarity. So what's the concentration of the HCN at the end? Well, 2x. So the concentration of HCN at equilibrium is going to equal 2 times 0.51, so 1.02 molarity. And that's number 7.